some work on functions. Function notation is something that I hope you're familiar with, although we will spend a little time working with some function notation. Problem 20 gives us this definition of a function. F of x is x squared plus 2x. And then they ask us to find various values of the function. So, for instance, f of negative 2, f of negative 1. In fact, let me put that in like this, f of negative 1. Because I want you to be able to follow along the action pretty carefully. Function notation is really expressing a rule. It's telling you what to do when you input the value of x. If I was to write this with empty parentheses, it'd be whatever I put here, I'm going to square it and then add 2 times that. So square it and add twice that. For f of negative 1, let's write it like this. I'll get negative 1 squared plus 2 times negative 1. So 1 minus 2, which should be negative 1. As far as graphing is concerned, this would be your x and this would be your y. So if you're going to make a little t-table, you'd have negative 1 and negative 1. Inputs negative 1, outputs negative 1. Oops, other way. So x and y. But they asked us for some other values as well. For instance, f of negative 2 would be negative 2 squared plus 2 times negative 2. What's f of negative 2 going to equal? 0. Good job. You end up with 4 minus 4, which is 0. So negative 2 goes with 0. Oh, is it cubed? Yeah. I like it squared better. So I'm sure that's what the author meant. The reason I like it squared better is because if you cube something, it's not going to change signs. Positive or negative, when you cube it, it's still going to be the same sign. But here you have to be a little bit more careful with the sign. So I do like it squared there. Let's continue though with a couple more. They do ask you for instance, f of 0, which I hope you can get, and f of 1/2. Some of you might be uncomfortable with this. So let me point out that you can again use your calculator to work on these things. If you were to originally put in your calculator that function, x squared plus 2x, so x squared plus 2x, then because we've adjusted our table to have the right table set up, and let me quickly remind you, second window table setup should be set so that independent is set to ask. Hit the second key, then the graph key. Then you can type in the values of x that we need. I have some here, I'll delete them. Negative 2, negative 1, 0, and then 1/2. Now when I press the enter key, that 1/2 is going to turn into a 0.5. That's okay. Still get the right answer, 1.25. Yay. So f of 0 times 0 is 0, and f of 1/2, 2 times 1/2 is 1.25. You could also write that as 5/4. So unless I specifically say I want a fraction, I'm not going to be picky about you giving me fractions or decimals. I do tend to like fractions better, but like I said, unless I specifically state I want it as a fraction or I want it as a decimal, whatever form you want to give it to me is fine. Okay, so that's kind of a basic example here. Let's do a few more problems with functions. Do you want another one like this, or are you comfortable with function notation? Another one like that? Let's take a look at problem number 22. This time our function is h of x is x squared plus 4 over 5, and we're asked for a bunch of different values here. I think I'll go through most, if not all of them. So we're asked for instance, h of 2. And the book asks us for h of negative 2. Let's do something a little bit different just because it's going to be the same as h of 2 if we don't. Well, you know what? We'll do h of negative 2. Why not? H of a minus 2, and h of square root of 2. So those are the 5 function values that we're asked to find. In each of these cases, you've got to go up into the function and replace that x by whatever I have here highlighted in green. So h of 2, well, 2 squared is 4, plus 4 is 8. So I end up with 8/5. Am I going to get anything dramatically different for h of negative 2? Not really. When I plug in negative 2, as long as I do it carefully, when I square this, I get 4 again. 4 plus 4 is 8. So 8/5. So far, so good. How about h of a? Yeah, there's not much we can do here. When you plug in the a, you get a squared plus 4 over 5, and that's it. There's nothing more you can do. These aren't like terms. I can't combine those in any way. So we're done there. Let's try h of a minus 2. So that'd be a minus 2 here, quantity squared. Cooper, when I square that out, do I get a squared minus 4 or a squared plus 4? Or? Well, how would I calculate that then? Foil it. Yeah, there we go. So we'd have to foil that one. So let me kind of continue that over here to the right. Let's do a minus 2 times a minus 2 up here. A squared minus 2a minus 2a again plus 4. So when I FOIL that out, I get a squared minus 4a plus 4 plus 4 again, right? And that one simplifies a little bit more. The 4 and the 4 can add together. I get a squared minus 4a plus 8 over 5. So that's my final answer for h of a minus 2. 4 plus 4 is where I get the 8. So I just combine the like terms. All right? Appreciate the question. Let's do the last part of this, which is h of the square root of 2. What's going to happen when I plug in the square root of 2 here and square it? So what would I be left with? 2. So this becomes 2 plus 4 over 5, or basically 6/5. So some work with functions there. And we're going to continue to work with some functions, although we're going to mix it up a little bit. I'm going to do problem number 36 next, but I'm going to change it a little bit there. So I'll try and get the notes scanned in and make the notes available along with the video. So I'll try and put that in the description. Moving on to problem number 36. F of x is 3x minus 1. Again, you're going to be asked for a variety of things. And let me share with you what those things are. First, I want f of 2x. And then I want 2 times f of x. And I'm going to do a couple bonus problems for us as well. So not necessarily in the book. F of x plus 2 and f of x plus 2. We'll start with the first one, f of 2x. So f of 2x, well, wherever there's an x, I'm going to replace it with 2x. So I'm going to plug that 2x into the rule for f. Can anyone simplify f of 2x for me? 6x minus 1. Now, am I going to get the same thing if I kind of sort of factor that 2 out front? No. 2 times f of x is going to look like this. It's going to be 2. F of x is 3x minus 1. So I get 6x minus 2. So it means something much different. You can't, when you are working with this notation, you can't just factor out the 2 because we don't get the same thing. And depending on the problem, they could be much, much different. These were kind of close. That's only because this is a linear example. So the bonus feature, f of x plus 2. It would be 3 times x plus 2 minus 1. If I distribute that, I'll get 3x plus 6 minus 1, or better yet, 3x plus 5. Now, isn't that the same thing as the other bonus item that I gave you? Good. Here, f of x, we already know what that is. That's 3x minus 1. And to that, I'm going to add a 2. And when I combine like terms, I just get a 3x plus 1. Ta-da! Let me give you an example of something called a difference quotient. Is there something else on problem 36? You okay there? All right. So something called a difference quotient, something you'll see in calculus, difference quotient. Difference quotient looks like this. It's f of x plus h minus f of x divided by h. When you calculate these, I'd suggest you do these 4 steps. First of all, find f of x plus h. Then calculate, I'm going to call this delta y. You don't have to call it anything, but it's just a way to label my answer from this step. Basically, you're going to calculate the numerator, f of x plus h minus f of x. And then what? F of x plus h minus f of x. Basically, it's the numerator. All right, and then simplify delta y over h. There should be some nice simplification we get there. So let's see that that's true for problem number, where is it? 44. Yeah. That's just my name for the numerator. You can call it You can call it B or N or whatever you want. But it's just a way so that I don't have to rewrite this whole thing again. F of x in problem 44 is 3x squared plus 2. My first job is to calculate f of x plus h. So I'm going to put in x plus h here. That means I need to take 3 times x plus h and square it. Now to square this, please don't just go x squared plus h squared. It doesn't work that way. You have to FOIL it out. Now I'm not going to take the time here because we're running low on time. But when you FOIL it out, you're going to get x squared plus 2xh plus h squared. Finally, let's distribute the 3. 3x squared plus 6xh plus 3h squared. And don't forget that 2 that's still hanging around here. So that's our first step, is to find f of x plus h. Let's work on the next step. The next step is to take f of x plus h, basically this answer, and subtract f of x. So how is that going to look? Well, our second step would be f of x plus h minus f of x. And that's going to be 3x squared plus 6xh plus 3h squared plus 2 minus 3x squared plus 2. All right, there's a couple things that cancel out, right? In fact, everything from f of x should cancel out. So the 2's cancel out, and the 3x squareds cancel out. These cancel out. So what's left? 3x squared plus 6xh. And there's no rhyme or reason to writing it one order versus the other, just the way I happen to write it. But this is what I called delta y. You don't have to give it any special name. What we do need to do is take this and divide it by h, and that's our last step. So 3h squared plus 6xh divided by h. Well, I can factor out an h from the numerator. I can factor out more, but I'm only concerned about the h. So I'll factor out the h times 3h plus 6x, and the h's cancel. So your final answer here is 3h plus 6x. When a derivative, you're going to take the limit as h approaches 0. So you're going to go a little bit farther to calculate a derivative. So, but we don't have to worry about that part here. No. I'll be really happy if you get here in either order. Yeah. Thanks. Okay, let's finish up with a little work on domain and range. So, domain and range. There's a couple ways to think of domain. The domain is the values of x that you can put into a function and have the function be well defined. So our domain, if you're thinking of this thing algebraically, is this. I'm going to be kind of very informal. Our domain is all real numbers minus, and this is set notation, any points that cause problems. So basically you're going to throw out points that do a couple things, that make the denominator 0 or make a negative underneath the square root. Those are the ones that we want to work with. So if you had 1 over the denominator, then the denominator can't equal 0. You'd have to throw out the points where that happened. If you had a square root, the part that's underneath the square root, the radicand, this has to be positive. Radicand is greater than or equal to 0. This is really informal. If I ever tried to publish a book writing like this, they'd laugh me out of the office. All right, but it works in a setting like this. You don't have to have fancy notation and understandings. You just have to have this kind of notation and basic understandings. So, problem like number 62, g of x equals the square root of 7 minus 3x. They want to know the domain of this function. Well, what I set up here is what we have to work on. We need to make sure that 7 minus 3x is greater than or equal to 0. Okay. So that means if I move this to the other side, negative 3x is greater than or equal to negative 7. And conveniently, we get one last reminder on this today. When you divide both sides of an inequality by a negative, what happens? Flip the signs. Good. So x is less than or equal to 7/3, because the two negatives are going to cancel each other out here. Great. So that's our domain. X is less than or equal to 7/3. You could write that as a graph. 7/3, arrow to the left. You could write it with interval notation, negative infinity to 7/3. Am I going to have a bracket or parenthesis around the 7/3 if I write it with interval notation? Bracket. Good. Now let's see the correspondence between that and its graph. Now I mentioned earlier that there's a really cool site called Desmos, desmos.com. When you go there, you can graph like lots of really cool functions very easily. So I'm going to graph y equals the square root of 7 minus 3x. And take a look what we got. Let me just adjust this for projector mode. There we go. So it starts here at 7/3, and then the graph goes to the left, doesn't it? I've got everything less than or equal to 7/3, which is what we expected. That's what we solved for when we graphed it over here. We got everything less than 7/3. So you should see a nice correspondence between the graph visually and what we calculated. Now, how about in the other direction? We know something about the x-coordinates. How about something in the y-coordinates? Well, the y-coordinates, we're not talking about the domain anymore. What would we be talking about? The range. Where do the y-coordinates start? What's the lowest that they go? 0. 0 and then all the way up, right? So the range would be 0 to infinity. So we've got our domain. That's your domain. It's pretty hard to work with the range without looking at a graph. So you want to have your graphing calculator around or Desmos. So the range would be 0 to infinity. Now 0 is going to get a bracket because the graph actually does touch the x-axis. It does get down to y equals 0. So there's your range. Let's do one or two more like this. Problem number 58. F of x is x to the fourth over x squared plus x minus 6. This is almost the fourth time today we've seen that polynomial. The sign's changed just a little bit. Sorry, I don't write these books. What could go wrong with plugging values of x into this function? What do we have to worry about? Thanks. The denominator being 0. So, Vanya, where could the denominator be 0, or how could I figure that out? How's it factor? So plus 3 and minus 2. So what values would I have to throw out of my domain? I mean, domain is everything from negative infinity to infinity except what? Andrew, what points do I have to throw out? And? Negative 3 and positive 2. Good. I want to make sure that the denominator is not 0. So our domain is x not equal to negative 3 and x not equal to 2. And I might see the book write it in fancier ways. One way you could write this is negative infinity to negative 3, parentheses, negative 3 to 2, union, 2 to infinity. I don't know. I'll let you get away with that. Again, you can see it on the graph when we graph it. So let me go to the graph here, shut this one off. Y equals x to the fourth divided by x minus, or is it, x squared plus x, x squared plus x minus 6. All right, so let me kind of zoom out a little bit. All right, so you can see that there's a little bit of a gap here. It's called a vertical asymptote, right at the places where we predicted, at 2 and at negative 3. As far as the range is concerned, that one's going to be a little bit trickier to deal with. There's a gap on the range too, but I'm not going to worry about that one for right now. Are we okay with the domain here? So there's your domain. Last one, problem number 64. Yeah. Yes. Correct. The domain, it's everything except these values of x. So the domain would be negative infinity, negative 3, etc. It's everything except those, because those would create a 0 in the denominator. But it doesn't get flipped. If you put in a negative 3, you'd have negative 3 to the fourth would be 81 divided by 0, which is undefined. Or 2 to the fourth is 16 divided by, again, 0, would also be undefined. So it'd be undefined either way. So we have to leave those out. The last one, like I said, problem number 64. G of x is, you know what? Instead of doing 64, let's do 52. Sorry about that. 52. F of x is 5x squared plus 4. Is there any place where the denominator could be 0? Or any place where you could have a negative underneath a radical? in this function? No. So your domain is everything. It's always defined. In fact, what does the graph of this look like? Does anyone know? Yeah, it's going to be a parabola. It's going to have some kind of a U-shaped. And if you took the time to graph it on your graphing calculator or otherwise, so y equals 5x squared plus 4, you're going to see a parabola that touches the y-axis at what point? 4. So what's the range then? Yep, range would be 4 to infinity. You can restrict these things. Let's see, I think the next problem, 54, asks you to restrict it between 0 and 2. Is that right? Comma. It's not liking it. Yeah. Don't know the right syntax on that one. But you can restrict these things, and it would change the domain if you just looked at different x coordinates. All right, we're going to leave it here, though. The range was 4 to infinity. And let me get you some homework. So for homework, try 19 through 23, 27, 35 through 37, 55 through 65. That's for section 2.1. I'll answer homework at the start of class next time. So if you have any homework questions, or better yet, don't forget that Mimi will be here at 8 o'clock. So until page 89. See ya!